Hello doctors, do you have any doubt about DHMP? So I will tell you about how should we write step by step with the side headings and with important diseases related to HMP. Let's see. HMP pathway, also known as the pentose phosphate pathway, because of the formation of pentose phosphate in the pathways. Glucose phosphogluconate pathway and also Dicken-Horecker pathway. This is the alternative pathway for the glycolysis and TCA for the oxidation of the glucose, and 1% of glucose enter in this pathway, otherwise glycolysis and TCA. It is the anabolic process because biosynthesis of NADPH and pentoses occur. It is the unique multifunctional pathway because of no ATP is directly utilized or produced, and there are several interconvertible substances produced which may be proceed in different directions in the metabolic reactions. Hence it is the unique multifunctional pathway. Next, we will see about the site of the HMP. In the tissue site, mainly liver, RBC, adrenal cortex, testes, mammary gland, adipose tissue, and intracellular site is cytosol. Starting compound is glucose 6 phosphate, and end product is fructose 6 phosphate and glyceraldehyde 3 phosphate. You should remember that the starting product and end product. The features of the pathway that it is the multi-cyclic pathway and no ATP generation or utilization occurs. 3 molecules of glucose 6 phosphate give rise to 3 molecules of CO2 and 3 molecules of 5 carbon sugar, that is ribose phosphate. We will see in step by step. Remember 3 molecules of CO2 and 3 molecules of 5 carbon sugar. So, here is the pathway divided into two phases. Phase 1 is and phase 2 is. Oxidative irreversible phase is 1 and phase 2 is non-oxidative reversible phase. It is the overall outline of the HMP. This is the oxidative phase, non-oxidative phase. First, glucose 6 phosphate converted into 6-phosphogluconate, then ribose 5-phosphate, and here in both steps NADPH is formed, and here is pentose sugar ribose 5-phosphate is formed. Then this ribose 5-phosphate, then using the enzymes Transketolase and Transaldolase, there further multiple reactions are occur. Can form nucleotide, coenzyme, RNA, DNA, etc. So we will discuss deeply these phases. First is oxidative irreversible phase. First, glucose 6 phosphate converted into 6-phosphogluconolactone. This is a difficult name, but remember the 6-phosphogluconolactone. 3 molecules of all, and then it leads to form 6-phosphogluconate. Then the finally ribose 5-phosphate. In this step, here 3 NADPH plus H plus and here 3 NADPH plus H plus and 3 CO2 formed from the 3 glucose 6 phosphate. These are the enzymes. Summary of the first phase. 3 molecules of ribose 5-phosphate required in non-oxidative phase, that will go into non-oxidative phase, and so multiplying the above step, we have 3 molecules of glucose 6 phosphate plus 3 H2 here and plus 3 NADP plus form 3 ribose 5-phosphate plus 3 CO2 plus 6 NADPH plus 6H plus. Then second phase is non-oxidative reversible phase. This formed ribose 5-phosphate here is formed xylulose and ribose 5-phosphate with the enzymes ribulose 5-phosphate 3 epimerase and isomerase. These are the two enzymes and form xylulose 5-phosphate, two molecules and one molecule of ribose 5-phosphate. Then use of thiamine, and this is the enzyme transketolase. Transketolase requires thiamine. Here form pseudoheptulase and glyceraldehyde 3-phosphate. Here one molecule of pseudoheptulose 7-phosphate and glyceraldehyde 3-phosphate, one molecule. Then after this reaction, using the transaldolase, these molecules formed in erythrose 4-phosphate and fructose 6-phosphate. Then these both xylulose 5-phosphate and erythrose 4-phosphate is leads to reaction with using transketolase, that's with thiamine. Finally form glyceraldehyde 3-phosphate and fructose 6-phosphate. Here one molecule of glyceraldehyde 3-phosphate and two molecules of fructose 6-phosphate. It is the summary of phase second. 3 molecules of ribulose 5-phosphate forms 2 molecules of fructose 6-phosphate plus glyceraldehyde 3-phosphate. It's the summary of both oxidative and non-oxidative. 3 molecules of glucose 6-phosphate, it is the starting product, plus 3H2O plus 6 NADP plus. It's formed 2 molecules of fructose 6-phosphate plus glyceraldehyde 3-phosphate plus 6 NADPH plus 6H plus. Significance of HMP shunt. It is the unique pathway that generating two important products, pentoses and NADPH. Let's see about the importance of pentoses. Useful for synthesis of nucleic acid, that is RNA and DNA, many nucleotides like ATP, NAD+, FAD+, and coenzyme. It is the star point that the complete pathway of the HMP shunt may not be required for the synthesis of pentoses. And here the importance of NADPH. NADPH is required for reductive biosynthesis of fatty acids and steroids. Hence, HMP shunt is more active in tissues concerned with lipogenesis. Example, adipose tissue and liver. For fatty acid synthesis, we should require the more energy. Then NADPH plus is the good source of energy. Hence, NADPH plus required. Then HMP is more occurs in the tissues that concern with lipogenesis. NADPH is used in synthesis of certain amino acids involving the enzyme glutamate dehydrogenase. There is continuous production of H2O2 in living cells, that is the free radicals reactions, and which can be chemically damage unsaturated lipids, proteins and DNA. This can be prevented to a large extent through antioxidant free radical scavenging reactions involving NADPH. This is one reaction that glutathione detoxifies H2O2, and this NADPH is responsible for regeneration of reduced glutathione from oxidized. Fourth point is microsomal cytochrome P450 system brings about detoxification of drugs and foreign compounds by hydroxylation reaction of NADPH. In further videos, we will see in detail detoxification reactions. Phagocytosis, that is the engulfing of foreign particles and microorganisms by WBCs. This requires NADPH. Special function of NADPH in RBC is that it maintains the concentration of reduced glutathione we previously seen here, and which is essentially required to preserve the integrity of RBC membrane. Also necessary to keep ferrous of hemoglobin in reduced state, so accumulation of methemoglobin is prevented. High concentration of NADPH in the lens of our eyes is necessary to preserve the transparency of the lens. And finally, we will see the related disorders of the HMP. First is deficiency of glucose 6 phosphate dehydrogenase. First enzyme is required in the HMP. It is the X-linked inherited disorder characterized by hemolytic anemia due to excessive hemolysis. Most people with the glucose 6 phosphate dehydrogenase deficiency have no symptoms, but some may be develop anemia and hemolytic jaundice. If exposed to certain drugs like antibiotics, antipyretics, or fava beans, increased in free radicals that causes the decrease in NADPH and damage to RBC, and then hemoglobin is free. Then person with the it is the note point that the person with glucose 6 phosphate dehydrogenase deficiency cannot support the growth of malarial parasite. And second disease is Wernicke-Korsakoff syndrome. It is the genetic disorder due to reduced activity of TPP dependent on the transketolase enzyme. The reduced activity of transketolase is due to reduced affinity for TPP. It is the thiamine. In the chronic TPP deficiency, transketolase enzyme has reduced activity. And the symptoms finally the weakness, mental disorders, loss of memory, partial paralysis. Symptoms are manifested in vitamin deficient alcoholics. Hence, here is a HMP pathway is over. If you have any queries, comment in and like, share and subscribe. Comment for next topic. Thank you.